Today's lesson is on solving quadratics by completing the square. We've been solving multiple different ways, one by graphing, one by inverse operations, and one by factoring. But the question is, what do you do if you can't factor the quadratic? Simple. We're going to solve by completing the square. Review alert! Do you remember how to factor perfect square trinomials? Last chapter, we learned how to factor perfect square trinomials. So this right here should look familiar to you. This is how you test to see if you have a perfect square trinomial. And if you have it, how to factor it. So you always check, are your first and third terms of your trinomial perfect squares? So can you take the square root of them and get an integer? So square root of x squared, we have x. Square root of 25 is 5. Multiply them together to get 5x. And then what happens when you double them? You get 10. So in this case, that is a perfect square trinomial. Let's check the second one. Square root, first and third terms. So we have x and we have 9. Multiply them together to get 9x. And now double it, we get 18. So both of those are perfect square trinomials. So now let's see if we can remember how to factor them. To factor perfect square trinomials, your answer will always be a binomial squared. For both of these, it's a binomial squared. So to find the binomial, take the square root of the first term, plug it in. Take the square root of the last term, plug it in, and now check your signs. Since they're both positive, positive here. Same thing here. Square root of x squared is x. Square root of 81 is 9. But in this case, check your signs. If one of them is subtraction, you need subtraction in your answer. And that's how you factor perfect square trinomials. Okay, here are the steps for completing the square. It's kind of complicated, so I went to the lake to relax. First, you want to put it in the form x squared plus bx equals c. Then you want to find b divided by 2 squared and add that to both sides of your equation. Then you want to factor the perfect square trinomial and solve for x. Now we're going to follow those steps to actually solve this quadratic by completing the square. The first step is to put it in the right form. X squared plus bx equals c, which just means it can't be equal to 0. You want to take the term that's at the end of your trinomial and move it to the other side. So in this case, I'm going to add 48 to both sides. So now I have x squared plus 8x equals 48. Step number 2 is this right here, b divided by 2 squared, and then you add that to both sides. Doing this step will create a perfect square trinomial on one side of your equation. 8 divided by 2 squared. 8 divided by 2 is 4, and 4 squared is 16. That 16 we have to add to both sides of our equation. We want to add it to the left to create a perfect square trinomial, and if whatever you do to one side of your equation, you have to balance it by doing it to the other side. So now we have x squared plus 8x plus 16, which is a perfect square trinomial because that's guaranteed anytime you do that step. And then the other side, 48 plus 16 is now 64. Now that we have the perfect square trinomial, we can factor it. And we just reviewed how to do that. When you factor a perfect square trinomial, it always ends up being a binomial squared. And then to fill in the blanks, square root of the first term of x squared is x. Square root of 16 is 4. Check your signs. Since everything is a plus sign, we have a plus sign here. And then it's still equal to 64. So we factored the perfect square trinomial. Now all that we have left is to solve for x. To solve for x, you have to just do inverse operations. So in this case, first we have this binomial squared. And what's the opposite of something squared? Square root. So we're going to square root both sides of the equation. When you square root something squared, they just cancel out. So on the left side, it's going to leave you with just x plus 4 equals the square root of 64, which is 8. However, if you remember from earlier this chapter, it's going to equal a positive 8, but it could also equal a negative 8. So I'm going to have a plus minus sign in front of that 8, and we're going to consider this solution when 8 is positive and consider this solution when 8 is negative. My next step is to subtract 4 on both sides to cancel them out on the left. So I have that x equals plus or minus 8 minus 4. Now, that plus or minus means I'm going to have two solutions. One of them, consider 8 is positive. What is 8 minus 4? 8 minus 4 is 4. But my other solution, consider negative 8. What is negative 8 minus 4? Negative 8 minus 4 is negative 12. So my two solutions, positive 4 and negative 12. That many math steps for one problem, that makes me hungry, so now I'm in my kitchen. But I think we better do a couple more problems so I really understand what to do. Let's follow the steps again to solve this new quadratic. First step, we have to get it in the right form, and in this problem, there's actually two steps needed to get it in the right form. On that last problem, we got that c value in the correct spot by adding it to the other side, but there's another thing that has to happen. If you notice, to have it in the correct form, you can't have a number in front of x squared, a leading coefficient. In this case, we have that leading coefficient, but we have to get rid of that. So to do that, you're going to divide all three terms by that leading coefficient. This leaves us with x squared minus 10x plus 14. Now we still have to get that c value on the other side of the equation, so we're going to have to subtract 14 on both sides. On to step 2, we have to do the b divided by 2 squared, add it to both sides of your equation, because that's the step that will create our perfect square trinomial. So my b value is negative 10, so if I plug that in, negative 10 divided by 2 is negative 5, and negative 5 squared is a positive 25. You have to add it to the left side to create your perfect square trinomial, but to balance the equation, we have to add 25 to the other side as well. Now I have x squared minus 10x plus 25, and negative 14 plus 25 is 11. So I'm done with step number 2. Step number 3, since I created a perfect square trinomial, I'm going to factor it. And to factor a perfect square trinomial, it always ends up being a binomial squared. Simply square root the first term and that last term to fill in the blanks. Square root of x squared is x, square root of 25 is 5. Check your signs. Because we have a subtraction sign, we have a subtraction sign in our binomial, and that is still equal to 11. To solve for x, we have to do inverse operations, and since we have a binomial squared, we have to undo that by square rooting both sides. When you square root the binomial, it just undoes the squared, leaves you with x minus 5 equals. Now the square root of 11 is not a perfect square, so instead of getting a long decimal, we're going to leave it as the square root of 11. But remember, common mistake is for students to forget the plus minus sign in front. You need that because we're always going to have two solutions. One where you consider a positive square root of 11, and another when you consider a negative square root of 11. Now I have to add 5 to both sides to cancel them out on the left, and I have plus or minus the square root of 11 plus 5. To get my two solutions, you just consider one using a positive square root of 11, and then get your other one when you consider negative square root of 11. So for 1, I have positive square root of 11. On your calculator, make sure that you close your parentheses before you add 5. And then to get my other solution, negative square root of 11, once again, close those parentheses before you add 5. And if you round your answers to the nearest hundredth, your two solutions should be x equals 8.32 and x equals 1.68. Wow, that was pretty intense. You better get to work so you don't forget all of those steps. Good luck with the lesson.